Okay, we're going to look at drawing the energy curve on your spreadsheet, and we're going to look at it for the second tab on the week 2 and 3 rapidly varied flow specific energy calc. So E over a bump, EG1 specific energy curve. This is it completed. I'm going to start off with a blank screen one so we can see how we get all the lines from the results in the spreadsheet. So I'll take that away. So here's the spreadsheet that we're looking at. We've done the calculations, see the video previously. We move further down now. We've got a setup chart ready for data to be put in to draw the graph. So we'll click on the line that's there. This is a 45-degree line. I've set some axes for the specific energy and the depth. We could change those limits if we wanted, but these will work for the numbers we've got in today. The first thing to do is complete this column. I'm going to colour that in this colour just to indicate this is data that we need to put in there. I've chosen a range of y from 0.4 to 1.8, so y is going up the screen here. It's going to see we want to calculate the energy for these values of y, and energy is just our normal energy calculation, y plus v squared over 2g, and I can just put this here so we know what y we're calculating. E we're calculating, so E equals y plus, what's the v squared? Well, it's q over a, and so we're going to put a brackets and we're going to use a capital Q fixed divided by by divided by b fixed divided by, oops, cancel that, fixed divided by the y that we've just selected. Probably need that all bracketed and squared, divided by 2 times gravity fixed. Okay, right, so we've got a value of E. We should have a reasonable number of decimals, 3, so it's down to the millimetre. If we drag that down, we'll get a nice curve appearing on the chart. Okay, that looks like an energy curve. We could start it from a bit lower, 7.3. Let me see, it zooms a bit around there. Okay, that's probably okay. It's 0.3, 3.5, I think, yeah, nice and even. Okay, right. We want to see what calculations we've done here. For one thing, there's a line across here which we could put in to indicate critical depth. So critical depth on the data, we could choose some values in here. Well, in fact, we want a horizontal line, so I've chosen between 0 and the lowest value of E that we've got. So it's going to draw a line across here. Right. Let's see, put in, what is that critical depth? Well, we've calculated y crit. Yep, equals the y crit that we calculated above there. And the next value we need is a copy of that. So it draws a straight line. That indicates our solution for y critical, and it's in the right place. We draw the graph, we see that it's in the right place. It's at the turning point of this curve, so we're more confident in our solutions. While we're looking at this data down here, we see that this, click on that blue line, we see that that 5-degree line is drawn there. Right, we want to put in the energy calculations that we solved. E2, remember we calculated E2 earlier, and E2 was 1.185. 805, so it's equal to there. And we want again the same value, so we put that in there and it draws a line there. So what's that saying? This is saying that the two solutions for the energy were here. One was at one was at that point, which is not actually identifiable apart from reading it off the graph. So it's about probably, well, in fact we have the two solutions at 0.95 and there's one now at 0.58. And we probably should have E1, the initial data, initial energy going in, which was 0.313805, and again the second one is in there. Okay, so let me zoom in slightly. We'll see this chart. We need to be able to identify all the elements on this chart. When you're talking about it in an exam, we've got the critical depth, we've got the energy and the two solutions before the bump, and after the bump, and the energy and the two solutions before the bump. We don't actually use either of those two solutions apart from the value of energy. Where's the height of the bump? Well, it's the difference between these two energy values. It's the difference between the horizontal distance on this chart here. Sorry, it's the vertical distance between these 2 points on the graph. Okay, so that's how to draw the energy curve within your spreadsheet. There's energy curves in some of the other examples which we'll come across as we get to them. Okay, thank you.